Your Android phone is lying to you. Right now, as you read this, there are processes running deep inside your device that you never turned on, features draining your battery that you never asked for, and settings buried so deep that most people never find them in a lifetime of owning a smartphone. You bought a phone with a 5,000 mAh battery. You were promised all-day performance. But by 2 p.m., you're hunting for a charger like it's an emergency. That's not a coincidence, that's design. And today, we are going to break it wide open. What if the reason your phone dies fast has almost nothing to do with how much you use it? What if the real problem is sitting quietly inside your settings menu, draining your battery in complete silence every single hour of every single day, even while your phone is locked, even while the screen is off, even while you sleep? That is not a theory. That is exactly what is happening on the majority of Android phones in use today, and the people who manufacture these devices know it. They have always known it. The settings are not hidden by accident. The defaults are not chosen randomly. And when you understand the system the way it was actually designed, everything about your battery drain will suddenly make perfect sense. Let's start with the number that should bother you. According to research published by mobile battery analytics platforms in 2025, the average Android user loses between 30 and 40% of their daily battery life to background processes they are completely unaware of. Not streaming, not gaming, not maps, background processes, silent, invisible automatic drains that begin the moment you finish setting up your phone and never stop. We are talking about apps that you opened once, 3 months ago, that are still refreshing data in the background right now. We are talking about your display making decisions about brightness that cost you hundreds of milliamp hours every single day. We are talking about network radios pinging towers on frequency cycles that your phone never needed to maintain. And none of this was explained to you when you bought the device. Here's where it starts to get uncomfortable. The always-on display feature, which is turned on by default on almost every flagship Android phone sold today, Samsung, OnePlus, Xiaomi, Pixel, is not a small feature. According to battery testing conducted by DxOMark, having always on display enabled drains your battery approximately 4 times faster during standby compared to having it switched off 4 times. That is not a marginal difference. That is the difference between waking up to 80% and waking up to 55% after a full night of your phone sitting untouched on a nightstand. Most people blame aging batteries. Most people blame the apps they downloaded. Nobody blames the feature that their manufacturer switched on by default without asking. And this is just the beginning. Think about what that means for a moment. Your phone is sitting face down on your desk. The screen appears off, but somewhere inside that display panel, a layer of pixels is still glowing, still rendering the time, still showing your notification count, still drawing power from your battery with every passing second. Manufacturers sell always-on display as a convenience feature. What they don't tell you at the point of sale is the precise cost that convenience charges your battery every single hour. The fix is straightforward and immediate. Go to Settings, find Display, locate Always On Display, and turn it off. On Samsung devices, it lives under Settings and then Lock Screen. On Pixel devices, it is under Settings and then Display. The moment you disable it, your standby battery life will change in a way you will notice the very next morning. But here's where it gets more complex, because the display is only one part of this story. Your screen refresh rate is another silent killer that most Android users have never questioned. Modern Android phones ship with displays capable of running at 90 Hz, 120 Hz, even 100 microWave. The number refers to how many times per second the screen refreshes its image. Higher refresh rates mean smoother scrolling, smoother animations, a premium visual experience. And phone manufacturers love advertising these numbers because they sell devices. What they mention significantly less often is what those refresh rates do to battery life when left at maximum around the clock. At 120 Hz, your display is redrawing itself 120 times every single second. That process requires power, constant, relentless, uninterrupted power. Studies from display technology firms show that running a display at 120 Hz instead of 60 Hz can account for anywhere between 15 and 25% more battery consumption, depending on usage patterns and screen on time. And here is the most important part of that equation. You do not need 120 Hz while reading a text message. You do not need it while checking your email. You do not need it while scrolling through a news article. You need it during gaming, during high-speed scrolling through social media feeds, during video content where frame rate matters. Outside of those scenarios, your phone is spending premium battery energy to refresh a screen 120 times per second so that a static image of your calendar looks fractionally smoother. The solution is to go into Settings, then Display, then Motion Smoothness or refresh rate depending on your device, and switch it from adaptive or high to a standard 60 Hz setting. On Samsung flagships, it is called Motion Smoothness. On Pixel phones, it is called Smooth Display and needs to be toggled off. On other Android skins, search for Display Refresh Rate inside your settings. The visual difference in daily use is nearly undetectable. The battery difference is not. Now we need to talk about something that goes deeper than the display, something buried inside your Android phone that almost nobody outside of the developer community knows exists. It is called the Developer Options menu, and it is one of the most powerful, most misunderstood, and most deliberately hidden sections of the Android operating system. Google and device manufacturers intentionally lock this menu away from normal users. To access it, you must go to Settings, then About Phone, then find Build Number and tap it 7 consecutive times. As you do, your phone will count down with prompts like, "You are now 3 steps away from being a developer." Enter your PIN when prompted, and suddenly a new menu called Developer Options appears inside your main settings panel. Most people never find this. Most people never know it exists. And inside it, there are controls that will change how your phone uses power in ways that the standard settings menu simply cannot reach. The first thing you want to look at inside Developer Options is something called Background Process Limit. By default, Android is set to allow what it calls a standard limit of background processes, which in practice means dozens of cached and partially active applications sitting in memory at any given moment, consuming RAM, keeping radios active, and drawing continuous small amounts of battery power. Each individual app doing this might seem harmless. A news application refreshing its feed in the background. A food delivery app pinging your location every few minutes. A gaming application keeping its session alive in case you return. A social media platform preloading content so it appears faster when you open it. Individually, each drain is minor. Collectively, across 10, 15, 20 apps doing this simultaneously on a device that is supposedly idle, the cumulative battery cost is enormous. Researchers tracking Android battery behavior in 2025 found that on devices with no background process management, between 12 and 18% of total daily battery consumption came exclusively from background app activity during screen-off periods. Inside Developer Options, under Background Process Limit, you can change this. Setting it to, at most, 4 processes is a strong starting point for most users. This forces Android to keep no more than 4 applications running in the background simultaneously, freeing RAM, reducing processor load, and cutting the continuous low-level battery drain that background apps collectively generate. Some users go more aggressive and set it to at most 2 processes, which yields even greater battery savings, but may cause slightly slower app launch times since applications will need to fully reload from storage more frequently. The sweet spot for most people is 3 or 4 processes. Change this setting, restart your device, and then monitor your battery over the next 2 days. The results will be measurable. But what if you want to see exactly which applications are destroying your battery right now in real time with precise data? Also, inside Developer Options, there's a tool called Running Services. This is essentially a hidden live task manager, a real-time diagnostic view of every single process currently active on your device, along with how much RAM each one is consuming and how long it has been running. When you open Running Services, what you find is often shocking. Apps you haven't touched in weeks, services running continuously that belong to applications you forgot you installed, background processes associated with system features you never enabled. One of the most common discoveries people make when they first open Running Services is that a third-party application, sometimes something as innocuous as a weather widget or a fitness tracker, has been running continuously in the background for hours, consuming memory and battery with zero interaction from the user. Running Services lets you identify these applications and then address them directly through settings in apps by disabling their background usage permissions. Here's something that mainstream tech coverage consistently fails to address. The problem of background app drain is not just about the apps you intentionally downloaded. A significant portion of background battery drain on Android devices comes from pre-installed system applications that come bundled with your device at the factory. Carrier apps, manufacturer utilities, bloatware that serves the interests of the company that sold you the phone, not your interests as the person using it. These applications often have elevated system permissions that exempt them from standard battery optimization rules. They can run in the background even when Android's built-in battery management would normally restrict them. And because most users never open them, never think about them, and never check their battery usage, these applications drain power completely unchallenged for the entire lifespan of the device. To address this, go to Settings, then Apps, and view all applications including system apps. Sort them by battery usage if your device allows it, or manually review the list for applications you do not recognize or never use. For pre-installed bloatware that cannot be fully uninstalled, you can often disable them entirely, which prevents them from running background processes. Disabling a system application you never use is not dangerous. It is practical. And on many devices, this alone can recover a meaningful percentage of daily battery life that was silently being consumed by software you never asked for. Now let's shift to something that most people think they understand but don't. Mobile data connectivity. And the way your Android phone manages network radios is one of the most consistently misunderstood sources of battery drain in the entire ecosystem. Most people know that using mobile data drains the battery. What most people don't know is that maintaining a 5G connection even while you're not actively using data also drains the battery significantly and constantly. Your phone's 5G radio is one of the most power-hungry components in the device. When your phone is connected to a 5G network, that radio is continuously maintaining the connection, processing signal, and handling the communication protocol overhead that 5G requires, regardless of whether you're actually downloading or streaming anything at that moment. The 5G radio does not go to sleep when you are not using data. It stays active, maintaining the connection, ready to deliver speeds you are not currently requesting. According to mobile network efficiency studies published in 2024 and 2025, 5G connectivity can consume up to 20% more battery than an LTE connection under equivalent real-world usage conditions. And this power consumption happens even when you're simply carrying your phone in your pocket without actively using any network-intensive applications. For users who live or work in areas with strong LTE coverage and do not frequently engage in activities that genuinely require 5G speeds, switching the preferred network type from 5G to LTE or 4G represents one of the most impactful battery life improvements available on a modern Android device. To make this change, go to Settings, then Connections or Network and Internet, depending on your device, then Mobile Networks, and select Preferred Network Type. Switch from 5G to LTE or 4G LTE. You will lose access to 5G speeds, but unless you are regularly downloading large files or streaming high-definition content over mobile data, you will rarely notice the difference in daily use, and your battery will thank you in a way that hours matter, not minutes. And while we are discussing network radios, we need to address something that most battery guides treat as a footnote but deserves far more attention. Wi-Fi scanning and Bluetooth scanning are two separate background processes that continue running on your Android phone, even when Wi-Fi and Bluetooth appear to be turned off. This is not a rumor. This is a documented behavior built into Android by design. Applications and location services use Wi-Fi scanning and Bluetooth scanning to improve location accuracy, even in environments where GPS signal is weak or absent. When these scanning features are active, your phone's Wi-Fi radio and Bluetooth radio are being periodically activated behind the scenes to scan for nearby networks and devices, providing location data to apps and Google services that have requested it. This happens silently, without any visible indication in your status bar, consuming power from hardware radios you believe to be inactive. Now let's zoom out and look at the bigger picture of what Android's battery ecosystem actually looks like in 2025, because there have been structural improvements in recent operating system versions that most users are not taking full advantage of. Android's adaptive battery feature, which has been developing and maturing since it was first introduced in Android 9 Pie, has become considerably more sophisticated in its current implementation. Adaptive battery uses on-device machine learning to analyze which applications you use regularly and which ones you rarely or never open. Applications that the system classifies as rarely used are placed in a restricted state that limits their background activity significantly, preventing them from running processes, refreshing data, or consuming power unless you actively launch them. This happens automatically, without user intervention, but it requires time to learn your patterns, typically several weeks of usage. And it works best when you have also manually reviewed your app permissions and battery optimization settings to ensure that you have not granted unnecessary exceptions to applications that do not need them. The key action here is to go into Settings, then Battery Usage, or App Battery Usage, depending on your device, and review the list. For every application that appears there with significant background consumption and that you do not actively use or that does not need to run continuously in the background, restrict its background activity. On Android, you can typically set each app's battery behavior to one of three states: unrestricted, optimized, or restricted. Unrestricted allows the app to do whatever it wants in the background. Optimized lets Android manage it. Restricted prevents it from running any background processes at all. For the vast majority of applications on your phone, restricted or optimized is the appropriate setting. Most apps do not need unrestricted background access. They have simply claimed it because the default allows it and users never change it. Here is the uncomfortable truth that ties all of this together. The default state of an Android phone, the state it ships in, the state it remains in if you never touch an advanced setting, is not optimized for your battery life. It is optimized for the feature experience that manufacturers want to demonstrate at point of sale. Brightness defaults are high because bright screens look impressive in showrooms. Refresh rates default to maximum because smooth scrolling feels premium during a 5-minute demo. Always on display is enabled by default because it looks futuristic when someone picks up the phone on a retail shelf. 5G is the default network mode because carriers and manufacturers both want to showcase next-generation technology. Background processes are left unrestricted by default because users associate app responsiveness with device quality. And capping background processes can occasionally make apps load 1 second slower, which feels like a problem even when it is actually a worthwhile trade-off. Every single one of these defaults costs you battery life. Every single one was chosen deliberately. And none of them are serving your interests when you are away from the showroom and using the device in real life, watching your battery percentage fall through the afternoon while you are nowhere near a charger. The question that follows all of this naturally is, how much difference do these changes actually make in aggregate? The answer, based on controlled testing reported by battery-focused tech publications in 2025, is significant. Users who implemented the full combination of these optimizations, disabling always-on display, adjusting refresh rate to 60 Hz, enabling dark mode, shortening screen timeout, restricting background processes via developer options, disabling Wi-Fi and Bluetooth scanning, turning off mobile data always active, switching to LTE where appropriate, and manually managing per-app background battery optimization, reported improvements in daily battery life ranging from 30 to over 50% compared to factory default settings. On a phone that previously died by 4 p.m., these changes can push the device comfortably past 9 or 10 p.m. On a phone that was already lasting through the day, they add hours of genuine reserve capacity. That is not a marginal improvement. That is a fundamentally different daily experience with a device you already own. Not a new battery, not a new phone. The same hardware, the same software optimized the way it should have been configured before it left the factory. But here is the part of this conversation that most guides, most YouTube videos, and most mainstream tech coverage never reaches. The real issue is not that these settings are hidden, though many of them genuinely are. The real issue is that the current model of Android device manufacturing creates a persistent structural tension between what benefits manufacturers and carriers in terms of showcasing features and what benefits you in terms of how the device actually performs across a full day of real use. This tension does not resolve itself automatically. It resolves when users understand the system well enough to reclaim control of it, which is precisely what every step described in this script is designed to help you do. The settings exist, the controls are there. Android, unlike some competing operating systems, does expose these controls to users who know where to find them, even when they are buried 3 or 4 levels deep inside menus that most people never navigate. The Developer Options menu is a particularly remarkable example of a set of powerful system-level controls that Google makes available to anyone willing to unlock them. Controls that give genuine, measurable, real-world improvement to the device experience, and yet which are deliberately obscured behind a 7-tap unlock sequence that ensures the vast majority of users will never discover them. What does all of this tell us about the future? The trajectory of Android battery technology in 2025 and looking into 2026 points toward 2 parallel developments that are going in opposite directions simultaneously. On one hand, battery capacity in flagship Android devices is increasing. Silicon carbon battery technology, which has begun appearing in devices from manufacturers like OnePlus and is expected to proliferate more broadly across the industry, allows for significantly higher energy density compared to traditional lithium-ion chemistry, meaning physically larger battery capacity in the same physical space. The first commercial phones with 10,000 mAh silicon carbon batteries have already appeared in testing and in limited regional releases. These are real advances, and they will meaningfully improve raw battery capacity across the industry over the next 2 to 3 years. On the other hand, the demands being placed on those batteries are also increasing simultaneously and relentlessly. AI features are now deeply integrated into the operating system of virtually every flagship Android device. Google's on-device AI, Samsung's Galaxy AI, the ambient intelligence features that analyze your usage patterns, generate summaries, process images, and operate as persistent background services, all of these consume power. They consume processor cycles, which consume battery. They consume RAM, which keeps the device's power management from entering deep sleep states. They represent a category of battery drain that is entirely new, barely a year old in its current form, and already significant in its impact on daily battery life. The devices are getting more powerful, the software is getting more demanding, and the defaults are still configured to prioritize features over efficiency. What does that mean for you going forward? It means that these optimizations are not a one-time fix, they are a practice. Every major Android update has the potential to reset to certain settings, re-enable features, or introduce new background services that you will need to identify and address. Every new application you install comes with default permissions that may include background battery access that you did not consciously grant. Every manufacturer's software update potentially reintroduces defaults that you previously changed. Maintaining control of your Android device's battery performance is an ongoing process, not a single afternoon of settings changes. The manufacturers are continuously optimizing toward their interests. The question is whether you are continuously optimizing toward yours. What happens to battery technology when AI becomes even more embedded in the operating system? What happens when always-on AI assistants that process audio and visual input in real time become standard features on mid-range devices? What happens when the gap between battery capacity and power demand widens further and the defaults become even more aggressive in their consumption? Because there is always a new feature to showcase, always a new capability to demonstrate, always a new reason to leave another process running in the background that the user never asked for and will never know about. These are not hypothetical questions. These are the questions that the next generation of Android users will be living inside. And the answer to all of them begins in the same place it always has, with understanding what your device is actually doing and having the knowledge and the tools to change it. The battery life you were promised when you bought your Android phone is still there. It is not degraded. It has not disappeared. It is being spent systematically and continuously on features and defaults that were chosen for reasons that have nothing to do with what you actually need. And now you know exactly where to start taking it back.